Okay, let's have a look here. Right. Okay, where did we finish? Trig equations 0 to 2 pi, so we're in radians. Okay, so let's get started. 155, we have sine theta. I can rewrite that as sine theta equals a half. So then we have sine inverse a half. And it's in radians, of course. So sine inverse of a half, that means theta equals pi over 6. But there's a second answer here. When is sine positive again? On the flip side here. So that would be 5 pi over 6 then. It's a mirror image. If that's pi over 6, then this length is pi over 6, which means from here to here would be 5 pi over 6. You can check the answer by simply typing in sine of 5 pi over 6, and you'll see that it's also a half. And if I check the answers in the book, 155 is correct. Okay, so we want to use more formal notation. Okay, 156 now. So that would be cos theta equals a half minus 1. So that's minus a half. If I take the 1 to the other side. And then if I cos inverse minus a half, that would be theta is 2 pi over 3. There's a second answer, which again I can get from the circle. When is cos negative? Here in this quadrant, and in this quadrant here. 5 pi over 6, or 2 pi over 3 is like here. So the second answer is on the flip side. That's pi over 3, that's pi over 3, so it'd be 4 pi over 3. So you can check the answer by typing in cos 4 pi over 3, and you do get minus a half. And likewise, cos of 2 pi over 3, you do get minus a half. So we're all good. Okay, the next one now. 157. You can divide by 2, obviously. So you'll just end up with tan squared theta equals 1, which means then that tan theta equals plus or minus 1. So there's 4 answers here. So we have to look at when tan theta equals 1 and when tan theta equals minus 1. Tan inverse of 1 is 45 degrees. Theta is 45 degrees, pi over 4. And then here, tan inverse of minus 1 is minus 45 degrees. Now we'll fix that up in a moment. Because what's going to happen here, the answer for tan is exactly opposite the positive answer. So if you just add pi here, you get 5 pi over 4. And you can test it out again. Tan of 5 pi over 4 is 1. And likewise here, you can just add pi, get on the flip side. So this minus pi over 4 answer, which is here, the flip side answer will be over here. So that's 3 pi over 4. And if you check it out on the calculator, tan of that is minus 1. And likewise, tan of minus pi over 4 is also minus 1. The only problem is the answer should be 0 to 2 pi. And you realize that going backwards by pi over 4, well, that's the same as going around the other way by 2 pi minus pi over 4. Which is 7 pi over 4. So you could change that into 7 pi over 4. And those are the 4 answers then for question 157. And I can check the answers here. And they are correct. Now let's have a look at 158. 158, you can rewrite that as sine squared theta equals 2 over 4, which is a half, and then you square root it. So you get plus or minus 1 over root 2. So if we look at the positive answer first, sine theta equals 1 over root 2. And then we have a look at sine theta equals minus 1 over root 2. So sine inverse 1 over root 2, or arc sine, as you might say in the States, that's pi over 4. And the second answer would be over here. So is that 3 pi over 4? Yeah. And then here, sine inverse of minus 1 over root 2. It's the same deal as earlier, minus pi over 4. That's in the negative. So it's going to be on the flip side again. I'll draw it here, sorry. That answer's in, oh dear. That answer's in the negative. All students take care. It's a negative, so it's in this, and it's in this quadrant. And next time sine is negative again is over here. So if that's pi over 4, that's pi over 4. So it'd be all of this plus pi over 4. So that's 5 pi over 4. And then it's the exact same situation as question 157. Minus pi over 4, you can convert that into 7 pi over 4. So the four answers are pi over 4, 3 pi over 4, 7 pi over 4, and 5 pi over 4. And like I said, if you want to check the answers, just type it in on the calculator. So 1 is correct. The first answer is correct. The second answer is correct. The third answer is correct. And the fourth answer is correct. Yeah, okay. So that's 158. Okay, I think I'll clear this off now for 159. 159. Rearranging that, I can get cotan theta equals minus 1 over root 3. I can flip both sides and I'll get reciprocal of both sides, and I'll get tan theta equals minus root 3. If I tan inverse minus root 3, I'll get theta arctan, leaves me with theta is minus pi over 3. And then we are here, and the next time tan is negative is over here, exactly 180 opposite that. So if I just add pi onto that, I get 2 pi over 3. But then pi over 3 is a negative, so we want to convert it into the positive angle. So just add 2 pi onto it. So my answers would be 2 pi over 3 and 5 pi over 3. And I can check here. 159, 2 pi over 3 and 5 pi over 3. That's correct. Okay, 160. I can get 3 sec theta equals 2 root 3. I'll divide by 3 and reciprocal both sides. So that's cos theta equals 3 over 2 root 3. So that gives me theta as, if I arc cos now, that's pi over 6. I can simplify this if I multiply above and below by root 3. Those will cancel with that, and I'll just get root 3 over 2. So it should be clearer that it's pi over 6. Okay. But the next time now, I'll get a positive cos will be down here. So if that's pi over 6, that's pi over 6. So 2 pi minus pi over 6. So 11 over 6 pi. So those are the two answers. I can check them. If you were to calculate cos pi over 6, you do get root 3 over 2. And 11 pi over 6, you do get root 3 over 2. So that's correct then. Okay, interesting one now with 161 and 162. You've got the equation 2 cos theta sine theta equals sine theta. And I know what they're doing here. They're trying to trick the student into cancelling sine theta, which is the wrong thing to do here. 2 cos theta sine theta minus sine theta equals 0. We have to factor out the sine theta, not divide it out. And that's 2 cos theta minus 1 equals 0. So either sine theta equals 0 or cos theta equals a half. This means that theta here could be sine inverse of 0, which is 0. And then the second answer is 2 pi. However, we're not permitted to include 2 pi because the interval is open at 2 pi. So it's only 0. And here, cos inverse of a half is pi over 3. But then that's in the first quadrant. And then cos is positive again in the last quadrant. So that's pi over 3, that's pi over 3. So all the way around would be 2 pi minus pi over 3. So that would be 5 over 3 pi. So it means there's 3 answers here: 0, pi over 3, and 5 pi over 3. And since it's an odd question, I can check it. 161. Now. Oh, I apologize. I'm so careless. I'm rushing through this. There is a second answer here. Sine is 0 twice. Once at 0 and again at pi. So careless. I'm so careless. So careless. 0 and pi, I forgot. For sine x, that's 0 when x is 0 or pi. And then cos x, that's 0 when x is pi over 2 and 3 pi over 2. Yeah. I don't know why oh, Stephen, come on. Be more careful. Gotta be more careful. I guess, after a full day of work and a long train journey, brain doesn't operate at 100%, sadly. Oh, well. Apologies. Okay. 162. Right. Cosec squared theta plus twice cosec theta plus 1 equals 0. Oh man, I feel so silly for that last mistake. Okay, move on. Right, I can factorize this quadratic, can't I? That's cosec theta plus 1 times cosec theta plus 1 equals 0. Cosec squared. Yeah. So actually that really just means cosec theta should equal minus 1, which means sine theta should equal minus 1, because cosec is 1 over sine. Which means that theta should equal sine inverse minus 1. which is minus pi over 2. And then the second answer here, so that's a negative. So the next time sine is negative is over here. Oh, well, you know, actually, this is kind of a special case, 90 degrees, because it's not in a quadrant. So I think rather than doing it this way, I'll just think about it as the graph. So sine is only at minus 1 once at a 3 pi over 2. Yeah. That's the only time it's at minus 1. Which that does correspond to minus pi over 2, by the way. And this time, this is what I must have been thinking of in the last question. This is the one in which it only happens once in a period. Yeah. Yeah. So I think there's only the one answer here. Because this quadratic is actually repeated roots. So although it looks like a quadratic, it's only one equation for us to concern ourselves with. Yeah. But it's an even question, so I can't know the answers for certain. But I think there's only the one answer here. Okay. Right, let's clear this off now. Well, I suppose if someone spots me doing something silly, you'd let me know in the comments. You can always trust people on the internet to point out your mistakes. 163. Which equation is that? Well, you see it starts at the origin, so it has to be a sine. The amplitude is 4. And the period, well, the period is 8 units. So the way to get the coefficient here for the period is it's 2 pi over the period. So that would be 4 sine pi over 4x. So that's the A and the B. And because this is an odd question, I can see that this is correct. 164. It's cost graph because it doesn't start at the origin, but it's upside down. It starts from the bottom and goes up, so it's a negative cos. The amplitude is 2, and the period is 2 units. Two units. So it'll be pi x, 2 pi over 2. Yeah, okay, I think so. 165. Okay, it's definitely a cos, but it only goes to 1, so it's just a 1 in the front. And the period is 1, so it's 2 pi over 1, so 2 pi x. That's 165. Yeah, that's right. Okay. 166 now. Okay, so we have y equals, oh man, that's not clear. Why do they do this to me? It's an upside down sine. I'm not sure about the amplitude yet. The period looks like 1 unit though. So that's 2 pi x. But what on earth is the amplitude? Do they want us to round? Um, just guesstimate it. 0.8. Can't quite tell on my printout. 0.8 is what I'm going to go with. Can't tell at all. Okay. Right, now for next time, for the following exercise, find A, the amplitude, B, the period, and C, the phase shift with the direction for each function. Yeah. Yeah. Okay, we'll have a look at that next time. All right, hopefully that's clear. Again, sorry about the confusion with that question earlier. Question 161. I really got to learn to slow myself down and not rush through these. Oh well, there you go. Okay, thanks for watching. We'll leave it there today. We got quite a lot done again. Up to 155 to 166. Not bad. Not bad.